What if I told you the fastest McLaren ever imagined wasn't designed by a human? No legendary engineer, no famous designer, no sketchbook, just an artificial intelligence trained on decades of Formula One data, aerospace engineering, and millions of driving simulations. And the most unsettling part, its design made experienced engineers question everything they thought they knew about building a hypercar. Every legendary McLaren began with an idea, a sketch, a conversation, a human obsession with speed. From the iconic F1 to the revolutionary P1, every masterpiece reflected decades of engineering experience and instinct. But what if the next breakthrough didn't begin inside a designer's notebook? What if it came from a machine that had never driven a car, yet understood speed better than anyone alive? Imagine the year 2042. McLaren quietly launches one of the most ambitious research programs in its history, not to build another hypercar, but to answer a question that has never been seriously explored. Could artificial intelligence design a faster car than humanity itself? Instead of asking designers where every panel should go, engineers fed an advanced AI system something far more valuable: everything. Formula One telemetry, wind tunnel data, Le Mans endurance simulations, crash analysis, thousands of aerodynamic patents, millions of racing laps, every success, every failure, every lesson ever learned. For months, the AI didn't produce a single design. It simply learned. It discovered patterns invisible to humans, relationships between airflow, tire deformation, structural flex, suspension geometry, and cooling efficiency that no engineer had ever connected before. Then, one morning, it generated its first complete hypercar, and almost everyone believed it was wrong. The body looked unfamiliar, the air channels seemed impossible, the wheel arches were shaped unlike anything McLaren had ever built. Even the cockpit sat several centimeters farther forward than expected. But simulation after simulation revealed the same astonishing result. It was faster, not by a small margin, by nearly 8% around an entire Formula One circuit. The secret wasn't more horsepower, it was less resistance. The AI treated air like another mechanical component. Thousands of microscopic aerodynamic surfaces constantly redirected airflow exactly where it was needed. Instead of fighting turbulence, the car embraced it. Its carbon fiber shell was generated using topology optimization, removing every gram of unnecessary material while strengthening critical load paths. No human would have drawn these shapes. They simply looked too strange. Yet every curve existed for a mathematical reason. Power came from a compact hybrid system unlike any previous McLaren. A lightweight twin-turbo V6 worked alongside 4 independent electric motors, one for each wheel. Rather than waiting for wheel slip, the AI predicted traction loss milliseconds before it happened. Torque shifted continuously across all 4 wheels, making the car feel less like a machine and more like an extension of the driver's thoughts. The suspension followed the same philosophy. Traditional dampers reacted to the road. This one predicted it. Using LiDAR scanners, high-speed cameras, and predictive terrain modeling, the chassis adjusted itself before each corner, each bump, and each braking zone. To the driver, the road simply became smoother. Inside the cockpit, almost nothing resembled a conventional dashboard. Every display appeared only when required. Controls rearranged themselves depending on the driving mode. Even the steering wheel subtly changed resistance based on available grip and vehicle balance. It wasn't replacing the driver, it was constantly coaching them. And then came the most controversial discovery. When engineers asked the AI to explain why it had designed certain components, it couldn't. The neural network knew they worked. It simply couldn't describe its own reasoning in language humans fully understood. For the first time in automotive history, engineers weren't teaching the computer was teaching the engineers. Entire departments spent months reverse engineering decisions made by their own creation. Some of those discoveries eventually improved McLaren's existing road cars. Others remained too complex to manufacture economically. At least for now, which raises a fascinating question. If artificial intelligence eventually becomes better at designing faster, lighter, safer, and more efficient vehicles than humans, who becomes the real engineer? The person who builds the car or the intelligence that imagined it first? Perhaps the future of performance won't belong to the fastest driver or even the smartest designer. It may belong to the algorithm capable of discovering possibilities no human mind could ever imagine. And if that day arrives, the definition of a supercar may change forever. Every generation of McLaren has redefined what performance means, but perhaps the greatest revolution won't come from a bigger engine or a faster lap time. It will come from a machine capable of inventing ideas that humans never would have considered. If McLaren revealed an AI-designed hypercar tomorrow, would you trust artificial intelligence to build the world's fastest car? Tell me your answer in the comments below. And if you enjoy cinematic automotive documentaries exploring the future of engineering, subscribe, because the next project we're uncovering may blur the line between science fiction and reality even further.